Hello, welcome to another Build With Me video. Today we're going to build this little circuit here. It does not have really much of a practical use, but what it is a practice board for surface mount soldering. All of the components on here are surface mount. So let's see what comes in the kit. Circuit board, piece of paper, and a little bag of components. We'll get to this in a minute. Nice little double-sided circuit board. And then a lot of tiny components. Now, other things that you will need in order to assemble this kit are, of course, solder, tweezers, soldering iron. It would be helpful if you have a magnifying glass or lens that you can look through, as these components are tiny. And the other thing that makes surface mount soldering much more enjoyable and effective is some flux. This is just some no clean flux. I will put the links for all of these products in the description below, for where I got mine from, including a link to where you can get the kit from. I bought a set of 3 of these kits, one to build up to see what it was like, one to film, and then there was one spare. I recommend that you do the same. They're very reasonably priced, and it means you can get extra practice. So let's take a look at the instructions. We've got our circuit diagram. Let's zoom you down a bit onto that. So it's based around a traditional 555 timer circuit. Very simple. Clocking out into a CD 4017 decade counter. Basically takes the pulses coming into it from the 555 and divides it up into 10 outputs. In fact, actually 11 outputs, because it has a carry output. So it'll count through all of these, and then it will, through the carry output, illuminate the 4 corner LEDs as you saw at the beginning. Further down we've got a little description of the board, which is helpful, knowing where things are. List of components. This is very handy for whenever you put components on the board, you can tick them off or stroke them out. It lets you know that you've done those positions and you're not chasing yourself. A little pictorial tutorial on soldering, suggestion on one way of doing it, and we'll try that out. And then again, pictorial for doing the integrated circuits. So without further ado, we shall get things organized and bring you in a bit closer so you can see what's going on as we assemble this. So this is the contents of the kit. The components, most of the passive components, are tiny. I think they're 0805 sized SMD parts. This is just a standard pencil. I brought you in so close, and as you can see on the bottom I've got a ruler here, and these are 1mm divisions, and then down here we've got 0.5mm divisions as well. So you may think to yourself, where do you start with putting together surface mount components onto a board? Normally on through-hole construction you always start with the smallest components, namely usually the resistors and diodes, move on to slightly larger components until you get the board populated. But pretty much all of these components are the same height. So you could, if you wanted, put them in whatever order you wanted to. But if you're not used to soldering and working with surface mount components, I would advise starting with the resistors and then the capacitors. The reason for this is that you will be new to doing this sort of soldering. You may take a little longer to solder each component in, especially at the very start, and the resistors are fairly tolerant of having heat from a soldering iron over a longer period of time, whereas your integrated circuits and your diodes and your transistors, they won't be as happy, and you may tend to have failures in those if you heat them for too long. So until you get used to it, and a good way of getting used to it is to do all of the passive components. Now the good thing about this kit is that there's only one surface mount value of capacitor, and there's only 2 of them, so it makes it quite easy. In other projects or kits or circuits that have multiple surface mount capacitors, you need to be very careful how you identify these, because there's no identifications on the packaging. Unlike the surface mount resistors, which we'll zoom in on a little later on, you can tell what the values are, but the capacitors, you don't. So basically what you do is you work one value at a time, and hopefully they have marked the value on the strip of the kit that you get, or if you buy the components by themselves, they'll come in a bag with the value marked on them. So what we're going to do is we're going to start with a circuit board here. We're going to follow to a certain extent their recommendations, the instructions that they provide on how to solder the surface mount components. We'll start off with the 2 capacitors, because they're the only capacitors that there are, so we shall do those first of all, and then we'll work on the resistors. We've got one value of one resistor, which is I think 1 meg ohm, and we've got 5 10k, and then we've got 15 330 ohm resistors. So we'll do each in turn. So I've brought you in a bit closer, and we've just got our capacitors here. You can see from the size of my fingers, we're zoomed in pretty close. So these come in a little strip, and there's a tiny film on here which is incredibly difficult to get off from just small sort of individual components. So what I have is I've got another pair of tweezers here which are really fine, but actually I can stab through that. There we go. Now something to be careful of whenever you're opening these surface mount components is that they have a tendency that they can spring out. So perhaps do this carefully, like that. Like that. Doesn't take much, it bounces them out. But do it in a place where they can't just bounce onto the carpet, because they'll be lost forever. So the instructions suggest that you put a little bit of solder on one pad for each surface mount component. And I find if I've got maybe 2 or 3 or any number of the surface mount components that I want to place that are all of the same value, I'll work on where I will tin one pad for each component that I need to place. So these 2 capacitors, this is C1 and C2, which go in C1 and C2. So what I will do is I'll just tin a couple of those pads. Oops, wrong one. This is what happens when you're looking at the screen and not at what you're doing. So, C1 and C2. What I'm going to do is I'm going to actually turn this sideways, this circuit board. Now the reason I do this is because my soldering iron's coming in from this side, and it's just so much easier. So what you do is you pick up your component, bring it over, and now I have to make sure that I'm putting in the right one. Yep, this one is for C1. Melt your solder and to keep hold of the component because it'll tend to just stick to your soldering iron, and then you're running around trying to wipe it off onto something. So same again. And we get it down and in place as best we can. As you can see, I'm a bit off on that one, so we just reflow that and move it. Then what we do is, let's just turn this around and we can flow some fresh solder onto the other side and make this joint. That one's not quite made. There we go. Then it seems a bit daft this, you're doing it 3 times. We just flow a little bit of fresh solder onto those fresh joints, and it just makes a much better joint. Now you don't have to do it that way. You can flood this with flux and then the solder will take much better. But if you don't have any flux with you, then good practice is just to reflow those joints again. So now let's do, there's a resistor, a single 10 mega ohm resistor. As you can see on this, it's got numbers written on the package, 1, 0 and 5. So that's 1 0 and 5 more zeros afterwards. The 5 is a multiplier. So that's a 1 meg resistor. And according to the parts list, that is for R2. So actually what we'll do with this component, we will flood a bit of flux onto the board. There we go. Should have tinned that first. And see how that's just a lovely shiny joint? That will be a good joint. We won't have to go over that one again. And so it's just more of the same. So the next set of resistors are these ones here. See if we can get reading those. Focus on upside down. 103. So that's 1 0 and then 3 more zeros. So that's a 10k resistor. We've got 5 of these. So if they go in upside down, come out upside down even, it's easier just to pick them up and drop them a couple of times until they do go the right way around, rather than trying to turn them around. They're so small. So this is R1 and then R14, 15, 16 and 17. So we have 14, 16, 17. You see what happened there? I let go too soon on the tweezers. And we had what's, I think, called a tombstone type effect. Except this one was standing on its side rather than it's on its end. Almost all the same way around.